Quick question. Do your end users always, and I mean always, without exception, work on company-owned devices and IT-approved apps? I didn't think so. So how do you keep your company's data safe when it's sitting on all those unmanaged apps and devices? 1Password has an answer to this question. Extended Access Management. 1Password Extended Access Management helps you secure every sign-in for every app on every device because it solves the problems traditional IAM and MDM can't touch. Check it out at onepassword.com/XAM. That's onepassword.com/XAM.
Welcome to Heavy Networking, the flagship podcast from the Packet Pushers network of fine podcasts, blogs, and videos for IT professionals. If you've ever freaked out about deleting an access list, even though you know it wasn't applied anywhere, you found your tribe. I am Ethan Banks, along with Drew Connery Murray. Connect with us on LinkedIn or our community Slack group, which you can join for free at packetpushers.net/community. I know you've only got so many hours to consume podcasts in a week, but I'm letting you know that Packet Pushers has been adding shows to our catalog over the last year. And one of those is Packet Protector, dedicated to security with a special focus on networking and hosted by published author and consultant JJ Minella and Packet Pushers' very own Drew. So if you admin a firewall, go sub to Packet Protector. On today's episode of Heavy Networking, we talk about a lapping strategy for CCIE Enterprise Infrastructure candidates. If you're not a CCIE Enterprise candidate, don't turn this one off, because our guest has figured out a number of clever hacks that make it possible for you to lab things you didn't think were possible to lab. So even if you're not prepping for a cert exam, you might pick up a tip or two to make your lab work a little more awesome. Heavy Networking welcomes Mason Reimert back to the pod. And as we record this, Mason is coming up on his first CCIE lab attempt, and he's deep in the zone of unreality where the upcoming exam is probably all he can see and the rest of the world is a bit fuzzy. So if you've ever prepared for a cert exam of any kind, you kind of know where Mason's at. Mason, man, thanks for coming back. Thank you for leaving your study bubble for an hour to share your lab hacks with us. It's good to see you, man.
Thanks for having me back. I'm glad to be here.
All right. Well, let's jump right in. Let's start with a gentle intro to Cisco's CCIE Enterprise Infrastructure track. EI replaced the routing and switching track that was the most popular CCIE track back in the day. So would you compare the exam topics for us? What are the big differences between the route switch track and the new Enterprise Infrastructure track?
Yeah, so what I always like to say is they took the meat of the old exam. They took, all the big topics, the routing protocols, and a lot of the layer 2 stuff. And they sort of made that 70% of this new exam. So 70% of this new exam is the traditional topics. And then the other 30% is split between software-defined WAN, software-defined access, and programmability. So the brunt of that is the software-defined portions. And then I believe a little bit of that is the programmability.
So when you say the traditional topics, we would be talking literally core routing and switching, different routing protocols, switching, layer 2 functionality, and then there's usually a pretty significant grab bag of other topics that you would need to know, like QoS, for example, and the such like.
Yes, and the transport technologies are still there too. So you're still tested on MPLS and DMVPN. And, the modern lab setup is sort of a hybrid. It sort of mirrors an organization where, you're mid-migration to software-defined. So you're going to have portions that you're tested on that are DMVPN, and you're going to have portions that you're tested on that are SD-WAN. And same thing for the LANs in this test. You're going to have, your traditional LANs, and you're going to have your fabric LANs. So they really took the big parts of the old exam and they meshed it more with what we see organizations going to today.
So do you have a strategy for labbing kind of the traditional topics of the route switch exam or the route switch portion?
Yeah, luckily that's like really, really well documented, especially because like a lot of people have emulators like EVE-NG or GNS3 that allow you to spin up more lightweight routers that support those core topics, because the core topics aren't resource intensive. They're only resource intensive at scale. So if you want to do an OSPF lab, you can usually do that on your laptop. If you have a decent laptop, you can run a VM, or you can even run GNS, which can run right on top of Windows and sort of acts as its own hypervisor. But it's not that hard to lab the traditional topics. And there's so many lab guides and there's so many different ways. Cisco has VIOS, which is their virtual IOS. That'll support, 99% of the traditional topics. There's a few topics in the traditional section where you do need iOS XE. But most of the traditional topics you can get away with VIOS, or you can even use Cisco's IOL, which they've released in the newest version of CML, which is basically it used to be an old internal build of iOS on top of Unix that was really, really lightweight and it would boot in like seconds. And they've taken that and they've released it to the public inside of the new version of CML.
So what I'm taking away is if I've got a laptop, I can get through a lot of the labbing just with that laptop.
I would say yes. And I would say where it gets kind of tricky is, and we'll get into this more later, but you're going to do multiple passes through the blueprint. And in the first pass, you're focusing on the technologies in isolation. But once you get into that second or third pass, you're focusing on the interoperability between the technologies.
Mm-hmm.
And the tricky part there is you need the scale. So
Okay.
while you might be able to do a BGP lab on your laptop with 16 gigs of RAM, when you start spinning up routers for transport for MPLS to do multi-protocol BGP and PE to C routing and stuff like that, those are traditional topics, but simply because of the amount of routers you need to effectively lab it, it gets clunky.
Yeah, it
Good to
used to
know.
be you'd need something like as many as 8 routers and maybe 4 switches to effectively lab up what you needed. Is it still about that, or is it more now?
So I know how many I use because I'm limited in my CML node license limit. And I will say I have done like my favorite MPLS lab, for example, is an MPLS core that's probably around 6 routers, and then 2 customers that have 2 to 4 routers each. So I would say like if you want an interoperable MPLS lab where you're studying the different PEC protocols, you're probably looking at around 10 routers because there's certain things like people build a MPLS topology with 2 routers and they'll never see some of the different labeling stuff that you're going to be asked about on the exam because they're only using 2 routers. There's certain things they won't hit. You know, you'll never have a black hole because you only have 2 routers. So even though you think you might be effectively labbing these and you might be getting to, you know, the finish line that you think you got the technology working, you're not going to hit the problems you need to be hitting to know how to resolve them.
Hmm. Which you can expect them to throw all kinds of odd things like that at you on the actual lab. That is the point of it. It's not to test that you can do something with OSPF. It's that you can work with OSPF in a specific complex scenario that requires you to understand intimately how it works in relation to other technologies that have been deployed. Well, okay, Mason, let's talk through the harder things to lab and their requirements. By harder things, I mean the not traditional stuff that you mentioned earlier. And the first one is SD-WAN. That's a new component to EI here. How would I lab that up?
So SD-WAN, the Cisco SD-WAN solution has 3 control components. So you have 3 base VMs that you need that can run inside of CML or EVE-NG as virtualization platforms or even GNS3. Those 3 control components, only one of them is pretty heavy. The manager itself that hosts the web UI for the administrator, that does need a decent amount of RAM. I believe it's 16 to 32 is the recommendation. I think I set mine to 20 and I'm usually good. And then the other 2 control components are more like routers. They just have different roles. So those only need like 4 gigs of RAM. So aside from those 3 control components, which you can download from Cisco and you can stand up in CML or EVE-NG, you just need enough resources to be able to run them. And that's not usually that hard. If you were doing those bigger traditional labs, you probably have enough virtualization space to make a 2 or 3 branch SD-WAN implementation. And there used to be some license requirements, and a lot of people don't know this yet, but the need for a Cisco Smart account to lab SD-WAN has gone away. So they
Hmm.
added a button called the pay-as-you-go license button. Basically, what it'll do is it'll throttle your WAN edges down to 25 megs a second, which doesn't matter for a lab, and it will let you generate unique IDs for your WAN edges, which are essentially the licenses that you used to need a license file for. So if you're reading a tutorial or you're reading a lab guide and it says you need to generate a license file and download it, as long as you're running a new enough version of Cisco SD-WAN Manager, which if you're using the version that's on the exam, you will be, you don't need to do that anymore. So they've actually taken some of the barriers away, as well as the SD-WAN images are now included with CML 2.7 and newer.
Okay. But you need a box with plenty of RAM to get that controller up. So
Yes.
again, you said you're getting away with 20 gig and pretty much been okay. But
Yeah.
as always, more is better.
Yeah, and there's some knowledge issues that I've seen when people try to lab SD-WAN too, because you don't just need to know SD-WAN. Because you're doing this in a lab environment, you don't have all the cool fancy ZTP and CA stuff that Cisco does for you. So you have to roll your own CA. Now, there's a trick that I use, and a lot of other people use it, where they use OpenSSL on the controller itself to sign their certificates. But because you're running this all air-gapped, you need to do your WAN edge certificates yourself and your controller certificate. So you need to know how to generate OpenSSL, root CA, and then sign certs from that CA.
And you don't have a trust problem with that, since you'd be, I mean, if you're basically you're self-signing.
Yeah. So you're self-signing, but you're self-signing in a way that you have a CA certificate that you can distribute. So basically the first step in onboarding a router, like a CSR 1000V or a Catalyst 8000V virtual router, is to take the CA certificate and install it. So you essentially put it on the boot flash of the router, and then you import it into the router's trust store. So what that does is when it does that initial connection to the controllers, it now uses your certificate to validate them and form that mutual trust, instead of using the one that Cisco would use if you were in the cloud.
Yeah, you just add your own certificate authority as valid. You can trust this one. Yeah, by importing that certificate. Got it. On that pay-as-you-go license button, again, if I'm using that, that means I can stand up these SD-WAN nodes, and it's fine. I'm not generating a license file. I can stand up and tear down labs, and Cisco's not gonna balk at me. I'm not going to get a bill at some point, anything like that.
Yeah, it can at this point, it can all be air gapped. So there's nothing that you have to expose your lab to the internet for. The generation of those unique IDs is all done locally, and as long as you roll your own certificate authority, it never needs to talk to the internet.
Okay, so does this feel like the way then that Cisco wants you to do this? This is I mean, I don't know if they document this. If you're a CML, Cisco Modeling Labs, right? I don't know if they're a user of that. Do they say this is the way we want you to go about it, or?
I believe that was their intention when they put the images in CML. I know that in the real world, this is not how you would do it. No one wants to roll their own CA for this purpose when Cisco will do it in the cloud for you. I know there are organizations that do it, like government and finance. They do this, and it is a supported implementation. You can do enterprise CA in real life with this. But I think especially with that pay-as-you-go button and the inclusion of those images in CML, I think that's what they were going for. They're trying to make it more accessible to lab.
So what about Cisco SD-Access? That's also in the exam, and what are the components you're going to need to be practicing on?
So Cisco SD-Access is a lot harder than any other topic on the blueprint to lab, and it's solely because of resources. So the core of Cisco SD-Access is Cisco DNA Center, which is now Cisco Catalyst Center, but essentially it's a controller that manages iOS XE devices. So it uses a combination of SSH and NetConf and SNMP to configure and monitor your devices. So the component of DNA Center that's on the exam is software-defined access. DNA Center can do many things. It can do assurance, and it can control networks that are not software-defined access. But the specific thing they're asking you about on the exam is software-defined access, which is actually one of the most complex parts of DNA Center. So to run a DNA Center in your lab, the specs are a little crazy. So you need at least 40 CPU cores, and you need at least 150 gigs of RAM.
Oof.
Even with those specs, I still have containers crashing on me. I would say if you can go up to 190 gigs of RAM, that's when I can stop getting containers to crash. Luckily, they crash in a very nice order because the assurance ones go first, and you don't really care about those when you're labbing. So what you can get away with 150, but the reason behind all this is DNA Center is a bunch of microservices. I think there's around 200 Docker containers running under the hood of DNA Center. And then they have a cluster services network that they all talk over, which you never see. But that's the reason why even in a very small implementation where you're only managing 2 or 3 devices, you need all of those resources. A lot of people ask, can I scale it down if I'm only managing 1 or 2 switches? Well, it doesn't really matter how many switches you're managing. You still have to spin up those 200 containers.
Okay. Does Cisco provide these sort of minimums or recommendations for the hardware in regard to the cores and the RAM?
So they've gotten better. When DNA Center came out, it was only supported on physical appliances that were rebranded UCS servers. So basically, you couldn't run it in a supported fashion on anything other than their UCS servers.
Mm-hmm.
Now they've released an OVA file, and I don't use the OVA file. The problem with the OVA file is the specs in the OVA file are they're overdoing it. You don't need that many. That's what Cisco wants you to run it at. If you price your lab out like that, it's going to be a lot more expensive than it has to be. So what I do is I take the installer that Cisco gives you to reinstall their physical appliances, which is just an ISO, and I mount it to a VM with the requirements that I just stated, and that has worked well for me, and I know it's worked well for other people. But they have gotten better with the release of the OVA. They've at least given you minimum supported specs for running it in a virtual environment.
Okay. All right, so virtual DNA center / Catalyst center. What else is in there for SD-Access?
So you need switches that are manageable by SD-Access or by DNA center to use as SD-Access nodes. And the problem with that is these switches need to be able to do the Lisp control plane and the VXLAN data plane. And a lot of the virtual routers that we were using to lab the traditional networking, like VIOS or IOL, can't do those functions neither in the control plane or in the data plane. So most recently, we've been using something called the Cisco Catalyst 9000V, which is essentially an emulated control plane and data plane of like a 9300 series Catalyst switch. And that is fully manageable by DNA Center. The problem is because you're virtualizing such a heavy switch and you're virtualizing not only the control part of the switch, you're virtualizing the data plane, which means you need to combine the resources, and that combination of resources is about 32 gigs of RAM is what I think I was getting lucky with. And it doesn't really work out well when you have all these SD-Access roles, because SD-Access has a few different roles and you need at least one of each of those roles to build an SD-Access fabric. So if you have a distributed fabric, you're going to need 4 of these Catalyst 9000 virtual switches, which each take 32 gigs of RAM. So that's where it really starts to explode from a resource perspective. And that's why I recommend people get 2 servers, because I don't think it's feasible to run in a reliable manner DNA Center on the same hardware that you're running all these Catalyst 9000 series switches.
Wow. You mentioned Lisp. How deep do you need to get into the weeds on Lisp? Because that's kind of an oddball protocol that people might not be that familiar with.
The nice thing about DNA Center is it really handles all that for you. You're really abstracted from the Lisp process itself, especially because it's sort of like a hybrid Lisp implementation, because it's using the Lisp control plane, but it's not using the Lisp data plane. It can't use the Lisp data plane because Lisp can't encapsulate layer 2 frames. And we need to be able to encapsulate layer 2 frames to build a fabric. So that's why it's sort of this weird hybrid protocol. But you will not need to know Lisp configuration. You'll need to know some Lisp troubleshooting commands most likely, but DNA Center will deploy the Lisp fabric for you. All you have to do is give it loopback 0 interfaces with reachability across them. And it will use those loopback interfaces to piggyback off of for the Lisp control plane communications and its VXLAN tunnels.
Okay, so maybe just some troubleshooting commands.
Yeah, when I first started studying it, I was more trying to see how I could break it. So I would deploy it with DNA Center, and then I would remove some commands, or I would, shut down a loopback, and I would see, okay, this is the symptoms when this part of Lisp isn't working. And I honestly think the more complicated part of labbing SD-Access is not traffic within the fabric, it's traffic traversing in and out of the fabric. Because then it's up to you to interface your traditional network at your organization or in your lab with the SD-Access border node. And essentially that's just a VRF light handoff. But because organizations and in the lab are using so many different things to do that handoff, there's so many different situations to lab. Like you could have your SD-Access fabric handing off right to a Cisco SD-WAN device. And that's a really common thing. And that means that if you're labbing this, whether for the purpose of the exam or for real life, you need to be able to run not only SD-Access and SD-WAN, but you need to be able to run them both at once.
How about ICE? Is that part of this?
That is part of this. So that handles the host onboarding portion of SD-Access. So that will handle, what VLAN people get assigned to and what SGT for Cisco TrustSec they get assigned to. So it is on the CCIE equipment list and it is used in the lab. So you will touch it if you take the lab. It's not as big of a topic as DNA Center or as the traditional topics. You pretty much have to know ICE as much as it interfaces with DNA Center and SD-Access. So you have to know its role and you have to know how to tie it into the fabric. So you will need to run ICE. My recommendation is get yourself a server that can run ICE and DNA Center together. And then when you lab those software-defined topics, you can turn that server on because that's going to be a really powerful server. You might not want it running 24/7.
Anything else as part of the SD-Access unit?
I would say the one thing I'll mention is if you're going to use the Catalyst 9000V switches, you'll need a way to simulate .1x clients, so EAP clients, to authenticate to the fabric. Mm-hmm. Some people will put Windows inside of CML or Eve, and I think that that's a waste of resources. You can use Ubuntu or Debian, and you can use a software called WPA Supplicant, which is usually included in some distros of Linux because it's what's used to authenticate to networks natively. You can use that as a .1x client. It actually has really good logging, and it'll show you right where failures are as well. So if you're looking for a way to lab .1x, which you probably will when you get to that portion of like the ICE interoperability, I would say even if you're not comfortable with Linux, it's not that hard to use that aspect of it.
Let's pause for a message from today's sponsor, 1Password. Imagine your company's security is like the quad of a college campus. There are nice brick paths between the buildings. Those are the company-owned devices, IT-approved apps, and managed employee identities. And then there are the paths people actually use, the shortcuts worn through the grass to the actual straightest line from point A to B. Those are the unmanaged devices, shadow IT apps, and non-employee identities like contractors. And most security tools only work on those happy brick paths, but lots of security problems take place on the shortcuts. 1Password Extended Access Management is the first security solution that brings all these unmanaged devices, apps, and identities under your control. It ensures that every user credential is strong and protected, every device is known and healthy, and every app is visible. 1Password Extended Access Management solves the problems traditional IAM and MDM can't. It's security for the way we work today, and it's now generally available to companies with Okta and Microsoft Entra, and in beta for Google Workspace customers. Check it out at onepassword.com/XAM. That's onepassword.com/XAM. And now back to the podcast.
No, SD-Access is a beast. That's a lot of resources. And again, you're splitting this out into different physical boxes, it sounds like, of hardware, as opposed to one monster box with a zillion cores and tons of RAM.
Yeah, so I know people that do it in one box, and it's definitely doable. But my recommendation is two servers, one to run your network virtualization platform like CML or EVE-NG, and the other to run your ICE and your DNA Center. And that way you don't run into, I was just trying on one box and I was running into some latency issues in my network simulations because, DNA Center would be doing an operation or an assurance task on the databases and that would slow down the simulation side. It just seems better for me to run it on two servers and then just have a direct Ethernet link between those servers where I can, trunk VLANs and stuff and connect the DNA Center and drop it into my topology.
Okay. All right, so we talked through SD-WAN, we talked through Cisco SD-Access. What about automation? That's the other oddball, well, not oddball, new thing that they're adding.
Yeah, so automation it's tricky not because of the depth they ask you to go, but because of how out of the wheelhouse it is for most people taking the exam. And they ask you to use features, and they're called out on the blueprint that people just don't normally use. And even if they use it, they're not using it the way they're asking you to use it in the exam or on the blueprint. So the biggest part of automation are the APIs for DNA Center and vManage. And a lot of people will ask me, do you think I should memorize API calls? I don't think anybody should memorize API URLs or calls. What you should memorize is how to get to the API documentation in each Cisco product that's on the equipment list. So like in Cisco SD-WAN, you can go to /API docs. Or in DNA Center, you can go to tools and then developer toolkit. And if you know how to get to both of those places, as well as knowing how to authenticate to those APIs, then you're good. Now you need to also know an API client. So you need to know something like Postman or Python requests to allow you to utilize the documentation that you're seeing in those portals for those products. And I think that that's the big part of the automation section. But the other parts that they're calling out on the blueprint are guest shell and EEM. And guest shell is a newer topic, and people might be using it and not knowing they're using it in production. It's essentially a containerization platform for Cisco IOS XE. So it runs CentOS containers on top of IOX, which is a custom hypervisor for iOS XE. And then it gives you built-in Python libraries to be able to talk between iOS XE and the guest host. So you can do really cool things there where you can use EEM to call Python scripts on the guest shell side. And then you can, from the guest shell side, reach back over to the iOS side and run commands with built-in Python libraries. And there are some really cool things you can do with this. One of the tasks that I did to sort of get myself comfortable with this stuff is I built a homebrew syslog collector with EEM and guest shell. So essentially, the EEM part watched for syslog messages, and then it shipped them off to the Python container. Then the Python container wrote them all to a file.
So this is essentially little applications I can run on top of that switch.
Yeah. Normally it's used for stuff like the Cisco Thousand Eyes container or observability. But a lot of people will use it to sort of extend the automation capabilities of the switch itself locally, because you have a full Python interpreter and you can pass data between so easily because there's basically a shared guest folder where you can drop things on the boot flash of the switch and access them in guest shell, or you can drop them in guest shell and access them on boot flash. So there's not only that file level sharing, but there's also in the background, there's file descriptors that basically they wrap in libraries that you can just, in the guest shell in Python, you can import the CLI module and you can do a CLI.configure and pass it a string and it'll run that config command on the switch.
So should we also assume then that some familiarity with Python would be useful for this automation portion?
Yeah, Python is definitely the language that they hit you with, and you have to know how to do it in editors that you normally wouldn't do it in. Because when you're doing guest shell on switches, you're not able to launch VS Code on a switch. You're going to have to use Vim. So there are a lot of people that are comfortable with Python, but they can't write Python without the tab key and VS Code. And unfortunately, that's just not going to work here. You need to be practicing writing Python in Vim and writing Python when there's no context-sensitive help available, because that could be a situation that you're put in, especially if they're calling out guest shell on iOS XE. That's the only editor you have. There's not even Nano inside of guest shell.
A good tip, yeah.
It can't be complex Python. It's got to be fairly straightforward stuff. Loops and importing modules and just basic variables and right.
Yeah, I wouldn't say the complexity comes in the code. I would say the complexity comes in not having those things that we take for granted when we're writing the code. So when I first started studying, I was like, oh, I know the Python request library. And then I opened up Vim on a Cisco switch and I tried to write a GET request and I was like, wait a second. I always have the help. I always type request dot and count on, the tab key and the VS Code to help me. So I don't think it's the complexity of the code that's getting people. I think it's the fact that they practice in an easier environment than what they might be tested on.
Yep. Anything else related to automation that we should know, Mason?
I think the other big thing that I want to call out is data formats. So a lot of us as network engineers, we speak the data format of CLI, and that's not really compatible with automation. So we need to know things like JSON and YAML and XML and be able to see and create valid examples of those three data formats. So as we're working with these APIs, we need to be able to know how to get something from the API, whether it be in JSON or YAML or XML, change that value, and then post it back up to the API, which also means we need to know about HTTP methods. So I would say if there's no experience, if you have no experience with APIs or data formats or programming, I would say you need to not put this off and start this spaced repetition of learning it at the beginning of your studies. Because if you go through everything that you're comfortable with first, you're going to try to hit this at the end. And then the problem's going to be no matter how long you spend on it, you're not going to spend enough time, enough spaced time on it to commit it, because you're literally trying to remember specific commands and formats and syntaxes of data formats. So you need time with this stuff. So if this is the thing that you're thinking is going to be your weak point, I would say start with it and then come back to it every now and then.
The good news is when you start working with this stuff, it is I'm going to say easy. And I don't want to trivialize it for people that are struggling with programming. If you've never been there before, it's maybe less easy. But like you mentioned, the request library. Yeah, that's the Python library that is very well documented, and it's easy to use to write Python statements that can pull data from an API and give it back to you in a structured format, like JSON, and then knowing how within Python to work with JSON to be able to iterate over the data that's in that JSON blob and do something with it. It's something that is done so commonly in programming. If I maybe I mean it that way, that there's tons of examples of how to do it. And it's not like you're going to be, hunting for this mysterious, esoteric thing. It's very easy to find out how to do it and to get that done. And Mason, I agree with you. As you said, it's just doing it, just to start getting comfortable with it, pulling data from the API, working with the structured data set that you get back. Well, Mason, what would you say is the right labbing approach? You've mentioned a few things along the way, but what I mean to say is, do you learn each blueprint topic one at a time, or I mean, how have you gone about this? It's a mammoth amount of information to get your head around.
I think labbing in isolation on the first pass of the blueprint is totally acceptable. And that's what I did too. I went in order down the blueprint and I labbed one thing at a time. And I didn't focus on interoperability. I just wanted to get that thing working and then break it and fix it and figure out the show commands and take my own notes and put it in a format that made sense for me. I think for the first pass, that's completely fine. But anybody who's studying for their CCIE knows that it's going to take you more than one pass over that blueprint. So by the second pass, I would say that you should really be focusing on interoperability, because that's one of the biggest parts of the lab. Is a lot of people know these technologies in isolation, but then you try to put them together, especially some of these newer ones like SDA and SD-WAN, and you try to do a handoff between them and you're like, wait, I've never done these together. So I think as you progress in your studies, you should not progress not only from a depth perspective, but you should also progress from a size of your lab perspective, how many concurrent protocols and technologies you have running.
So you mentioned SDA and SD-WAN as one sort of logical interoperable test. Are there other, individual blueprints that you think make sense to maybe line up and try to get to work together?
Yeah, I would say definitely the different transport technologies. You should try to use them all together. So I know people who know DMVPN and I know people who know SD-WAN, but then you put them together and you have branches on one end of the topology that are DMVPN and one end that are SD-WAN. And there's not only implementation questions that you might have, but there's design questions. What are the best practices to hand these two technologies off to each other? And what's the best place in the topology to hand these two off to each other? And especially when you're dealing with sites with multiple transports out, whether it's out to the internet or to a data center, you need to know how to tweak these protocols in a way that you'll only see when they're working together.
Yeah, it's funny how you mentioned the word design, and I was thinking about that. Back when I did the CCIE route switch program, it was similar. You not only had to know individual protocols and lots of details about them, but how to integrate them, how they work together. And there was a design element to it, even though there is also the CCDE program, which is a different thing. And you don't have a lot of engineering implementation details on the DE so much as you do on IE. There's still this need you have to pass this exam successfully of the whole big picture in your head, the design. How does this thing work together? You got to be able to pull that off. If you just understand the technology and how to type in a command to make a thing go wee, that's not enough. They want you to have a bigger sense of it and know how to apply certain technologies in certain situations. Again, even though it's not the CCDE exam.
Yeah, and I think for a lot of people too, from a design perspective, a lot of people know how to do things one way. And especially a lot of these people that'll tell me, oh, I've done that in production, so I should be good. Well, you've done it in production, but you've probably done it in production one way. the CCIE is known for saying you can't do it this way, you can't do it this way,
Yes.
and forcing you to do it the way that they want it, which also may be the most obscure way. So you not only have to know how to do something, you have to know every way to do it.
That's another thing about the CCIE. It is not about how you would do it in production. It is knowing all the different ways that you might be able to do it because you are demonstrating the very highest level of competency with these particular technologies. So it might be a stupid thing that they're asking you to do, but that is what they expect you to know. Yeah.
Yep. And you have to face the fact too that there may be lab tasks on the exam that don't, the end result of that lab task is not a working solution. And that's just a way they have to write the exam where you may not even be able to verify the config you just did, but they're going to grade you on what they've asked you to do. So if you've done what they've asked you to do, even if that doesn't result in connectivity or doesn't make sense, you still have to do what they've asked you to do, not what's logical.
So we touched on, some of the resource requirements, and you mentioned you prefer at least a couple of servers, fairly beefy. Other recommendations?
Yeah, so I know a lot of the people that run these labs at home will use Dell R630s. And I think that that's a pretty good jumping off point. I know some of the training companies that will rent you racks will use R630s as well. So if somebody asks me for a recommendation, I say R630 is solid. You want as much RAM as you can get with as many cores as you can get, definitely no less than 40 cores. A lot of people will point out the fact that I run UCS in my lab, and they'll ask me, is there a reason you run Cisco branded servers? Does it run DNA Center better? The answer is no. I just had UCS servers, so that's what I used. But I know the most common and the most bang for your buck is Dell servers. And I would say if you can get two Dell servers, one can be a little less powerful because it's just going to run, your network simulation, your traditional topics, and your SD-WAN. But the other one, you really need to make sure you have the capacity to run not only DNA Center, but DNA Center and ICE at the same time, because those are two technologies that go hand in hand, and there's no value in having one and then the other. You need them both at the same time.
Now, can I run everything virtually on these two Dell R630s that you're recommending, or should I have some actual hardware like catalyst switches? Is there some benefit if I could get my hands on some kind of an actual switch hardware?
So I'll say you certainly can virtualize everything, and it's becoming more and more common, and it's becoming easier too. For me, I do have a rack of 3850s next to my desk. I think I have four of them next to my desk. The reason I run them is because I like to see the technology work in a way that I can connect things to the Ethernet ports and I can connect a laptop and join the fabric. That's mostly at this point, I would say that's personal preference. I would say, if you learn better with physical equipment, then 3850s are not expensive. If you have enough compute to run virtual Catalyst 9000s, then that's a great thing to do. I would say at least you should do the virtualization aspect because you'll need at least one Catalyst 9000 series switch because it's the only switch that supports something called Fabric in a Box, which is the entire SD-WAN fabric in one box. So it's all the roles. And that is something that's on the blueprint. So you'll want to lab that. And that's not supported on a 3850 or 3650 Catalyst. So unless you went out and bought a 9300, that would be something you'd want to virtualize. I will say, and I'll say exercise a word of caution with, especially right now, investing in physical equipment like 3850s or 3650s, because Cisco is in the process of redoing SD-Access. They won't admit that they're redoing it, but they've announced that they're going to start supporting EVPN fabrics alongside Lisp instead of Lisp. And they say that Lisp is still going to be their primary for now, but I would not put it past them to sort of lean more to the EVPN side in the future, just because it's what all the data center people know. And, EVPN is so much more common than Lisp. And what I'm getting at here is that the 3850 and 3650 cannot and will never be able to run the EVPN version of SD-Access. So if you're buying stuff now for a lab attempt like a year and a half down the road, don't buy physical switches. Buy servers. They're more extensible. You can virtualize a Catalyst 9000 series on it now, and you'll be able to virtualize the new Catalyst 9000 series virtual on it then. So I would say err on the side of virtual, if you find yourself running out of virtualization space and you have a stack of 3850s at work and you can grab some, then sure, you can save yourself that room on your hypervisor.
Now, you used two words I didn't expect to hear you say together in the course of this discussion, which were not expensive. So what, you said I could get a hold of some, well, I think you said 3850s and they were not expensive. You better define that.
Okay, so I I buy all my lab stuff on eBay, and
Yeah.
people think that all this stuff is super expensive. I got a 9300 the other day for $120.
Working?
And yeah,
I mean, I asked that seriously because I spent my time with eBay,
yeah.
and when you get down to gear that's that cheap, usually
Yeah.
there's a catch.
So there
Blown power supply, or there's something
yeah.
wrong with it.
So there
You got to
was a there
fix.
was a catch. It was dropped on the corner,
Okay,
which rendered one of the Ethernet ports not usable.
not
But I
usable.
took
Maybe couldn't rack it if it had bent or
yeah,
something.
yeah,
Whatever.
but
Yeah.
I
Okay.
took the switch apart and I actually fixed that port and then put it back together, and I got a working 9300 that I can lab fabric in a box with for $130. But that's an anomaly. What isn't an anomaly is being able to get 3850s for around $50. You can get a 3850 for $50. You can upgrade it to iOS. I think it's like 16.9, and that can run the Lisp version of SD-Access just fine.
Okay, so you sort of anticipated a follow-up question. It sounds like you're comfortable then getting gear off the secondary market for your lab.
Yeah, and the reason is because even though everything's smart licensing now, the enforcement piece doesn't exist in any other product on the blueprint except ICE. So ICE has a 90-day evaluation and it'll lock up after that. You can get around that by just taking snapshots of the VM in your lab, or you can just reinstall it. But everything else, every other thing on that equipment list is smart licensing without enforcement. So when you're buying these switches secondhand, you can turn on the DNA Advantage license, which is what's needed to lab SD access, and you're not using it in production. You're not passing actual data through it. You're just using it to study. So that's been what I'm doing.
Well, maybe I don't want to build my own lab, Mason. Maybe I want to do something else because of the time, money, noisy. I've got a spouse in the house that doesn't want to listen to fans whirring all the time. Have you rented a rack? Is that something you think is a good idea?
So I actually have. I went through the Micronics boot camp with Narvik, and I got rack rentals through him and through his counterpart Terry, which does the SDA and DNA center side of his boot camp. I will say that rack rentals are much harder to find now than they were for route switch. And most of the rack rentals that you'll find are bundled with boot camps. It's very, very hard to find a rack rental for the parts that you would want a rack rental for. You can find people and even subscriptions like I&E that will let you run the traditional routing and switching and the SD-WAN side, because I&E came out with an SD-WAN course and they actually let you lab it along with the course. It's pretty cool. But those sites do not have the SD access component, which is the thing that most people would want the rack rental for, because that's the thing that's hard to run.
Mhm.
So it's very, very hard to find one of those things that isn't tied into a boot camp. I will say KBits, the training site, they have rack rentals of DNA Center. I believe you need to subscribe to a boot camp there. And then Micronics also has rack rentals for DNA Center, but once again, that's a boot camp as well. So it's very, very hard. You can find rack rentals for the traditional stuff and for SD-WAN, but if you want a rack rental for DNA Center, it's pretty hard to find unless you're doing a boot camp or you're using something like dcloud, which in my experience and my opinion is just simply not enough for the exam. And even if there was a rack rental for SD access, I would be hesitant simply because I think I've learned the most about SD access by breaking it
Mm.
and reinstalling it and spinning it up and tearing it down. And if you're using a rack rental, you need to really optimize your time, and you're only going to have enough time to do so many things. And when you're working with something as heavy as DNA Center with all these containers and you're starting them and you're stopping them and you're turning it off and you're reinstalling it, you're going to burn through that time incredibly fast. So I would be hesitant doing any sort of time-based learning on DNA Center because it's just going to take you that long.
Do you see a possibility of building your lab in public cloud infrastructure as a service like AWS or something like that? Or is that unthinkable because of expense?
I don't think it's unthinkable, and I think there are certain features that are certainly there at this point now that I would say is not a bad idea. The DNA center in the cloud is pretty expensive, And because of the way public cloud works, if you want to keep that DNA center instance there, you're going to have to pay for storage to retain it. So you're either going to have to reinstall it every time, or you're going to have to pay for the storage between study sessions. Now, you can run the Catalyst 8000V in the cloud, which is an SD-WAN edge, and that would actually help you lab the SD-WAN cloud on-ramp portion of the blueprint, because that's in the blueprint now, interoperating with AWS and Azure for SD-WAN. So there are pros to that. I will say, I think the reason we don't see people doing it is because it's simply more expensive. And but like you said, if cost isn't your issue and your issue is space and noise, then it's a viable option. But if you're looking for a cheaper way out, I would say that's not the place to look.
Have you looked at Container Lab at all?
I started looking at it and I watched a demo of it a little bit ago, and I think it is really cool and I think there's something there. I haven't had time to look at it because I've been studying so much, and I think a change to my methodology at this point is probably not in my best interest, but I did want to circle back to that after I'm done studying, because I definitely think that could take some of the mundane parts of studying out, because I was talking to someone the other day and basically talking about how I feel like studying is more building up and tearing down the time than I actually get with the actual protocol that I'm trying to lab. So I think that things like Container Lab will definitely help with that in the future.
Yeah, for folks who don't know, Container Lab is essentially a free open source tool where you can run containerized instances of network OSs, and I believe Cisco has some, and so Cisco supports some of those. So just another option as you're thinking about lab environments.
Mason, any other crazy lab tips you want to mention before we close?
Yeah, so I think my biggest piece of advice is, if you think you know it all, you probably haven't even hit that peak yet. Because I was there. I was there probably around this time last year. I was like, yeah, I could go sit this thing. And then I was sort of seeing the level of training that the boot camps did, and the level of training that, people who have failed. And I'm like, wow, these
Yep.
people know more than I do. And they just came out of this and said that, they couldn't pass. And that sort of made me sit back and reflect. And I'm like, yeah, I'm looking at this blueprint and I'm saying, I know this, but how deep do I actually know it? If I didn't have context sensitive help, if I didn't have a design guide, if I didn't have a CLI reference guide, could I stand it up? Could I troubleshoot it? Could I design it? And that's really what you need to ask yourself, because this is an expert level exam and they removed most of the verbs from the blueprint. There's no longer implement this, troubleshoot this, design this. You need to hit those for everything. So you need to be an expert in each of these topics. And I think there'll be a point where you think you know it all, and then you'll go through the next pass of the blueprint and you'll find more stuff you didn't know.
I'm curious, just for my own information, like, do you work with physical notebooks, like alongside all of the virtual and hardware work, or is it all just online and ones and zeros?
So my master of my notes lives in Notion,
Okay.
but I don't think that putting it into Notion, the act of putting it into Notion, does not help me as much as the act of writing it down. So I would
Yeah.
never be able to keep track of physical notes, and I wouldn't want that to be my primary source of notes. But like when I'm in a boot camp, I'm taking physical notes on paper, and then later I'm putting it into Notion. And then if I want to study out of Notion, my method of studying is copying from Notion back onto physical notebooks.
Okay, so physical notebooks are part of your study process?
Yeah, just because I think the writing contributes to retention.
Mm-hmm.
My version of that was blogging. I'd work on a lab or I'd read something in an exam guide, and I'd blog to try to help with that retention, because it would, writing it out or typing it out in some form demonstrates where you think you understood it, and then you're trying to write it out to explain it. And you're like, crap, I actually don't know how this works. I got to read this again. Yeah.
Yep.
Well, Mason, best of luck, man. I know this is the middle of August as we record this. You haven't done that first attempt yet. When is it? How far away are you?
So I fly out the 25th of August and I take the test on the 27th of August.
Okay, man.
Coming
So
up.
good luck. I mean, what do you think your odds are?
I I think given how many people I know that I would classify as well smarter than me who have taken it and it has taken them 3 tries, I think that it would be a huge anomaly if I managed to pass the first time. So I'm not expecting a pass. I'm expecting to know more about what they expect of me.
Okay. Okay.
That's
So
a good way to think of it. Yeah.
you're hopeful but humble.
Yeah, yeah.
Yeah. It'd be nice if you passed that first time for sure. But yeah, okay. Going in for that information gathering. Mason, your blog is masonreimert.com. And I don't know if you have much time to be blogging these days, but you've got some things posted there that you've shared with people. Can you tell them about that?
Yeah, so I made my most recent thing is a software defined access workbook. So I was struggling to find resources that were accessible for software defined access. A lot of the software defined access material was included in boot camps that were really expensive, or maybe you just wanted the software defined access portion. So I made a little workbook. I think it's like 25 pages that goes through standing up the infrastructure, building a fabric, and then some troubleshooting of the fabric.
Okay. And Mason, I know we can find you on LinkedIn and we can find you on Reddit. Are you pretty active on Reddit?
Yeah, so I check r/CCIE pretty much every day. So I respond to a lot of stuff on Reddit, and LinkedIn is definitely the best way to message me if you want to message me.
Okay, good stuff, Mason. And again, good luck on the CCIE attempt. We're looking forward to hearing how it went for you and what you thought. Although you haven't, I mean, you were fairly free to talk today because you haven't taken the exam yet. I mean, after the exam, it might be a little more awkward because they
Yeah.
make you sign that thing. So.
Yep. Yep.
All right. Well, hopefully you got something out of this. There's a lot of, if you picked up on what Mason was putting down, lots of tips on how to make the most of your lab environment if you're deep into Cisco technology. So again, thank you for listening to Heavy Networking today. Favor, would you leave us a rating on Apple Podcasts? We would appreciate that. There are thousands of you that listen to this show, but we know there are actually millions of people out there who are interested in networking. So leaving a podcast review would help other people discover the show, and we'd like that. If you have a question or a comment about this episode, you can leave a comment on the show notes page at packetpushers.net or send us your thoughts via our follow-up page at packetpushers.net/follow-up. Seriously, we would love to hear from you. We read every comment that comes through and we respond or acknowledge your correction if we got something wrong, etc. And did you know that we offer all of our podcasts as audiograms on YouTube? Yeah, we do. If you love YouTube, you can listen to every show we offer from there. Just search for Packet Pushers in YouTube to find our channel. And all of our podcasts are sorted for you and posted every time a new show goes up. I have been Ethan Banks, along with Drew Conway Murray. You can connect with us on LinkedIn or the Packet Pushers community Slack, and please do that. Maybe you have a story that you would like to share on a future episode. Would you just please let us know if you have that story? We love new voices on the podcast. They make for a bigger community, more perspectives, and because we don't want to bubble here. None of us is as smart as all of us, so share what you know with the collective community consciousness. We make recording a show with us as easy as possible. Just slide into our DMs on LinkedIn or Slack and pitch your story. Last but not least, remember that too much networking would never be enough.